Dear participants, good morning everyone. We are going to start our session within a 2 to 3 minutes. The source person already has joined us and he's taking some time to make the all kind of management. Then within a 2 to 3 minutes, we are going to start.
अब आवाज आती है?
यस सर, आवाज आ रही है आपकी। म्यूजिक नहीं आया अभी।
ठीक है, ठीक है, ठीक है, ठीक है। बस मेरे को 2 मिनट दे दो, मैं सब सेट करके फिर स्टार्ट करता हूँ, ठीक है?
बस साउंड आ गया है उसका म्यूजिक का प्रॉपरली।
ठीक है ना,
ओके।
स्टार्ट। सॉरी यार।
जी सर, जी सर। तो shall I start sir?
यस, यस।
Okay. So, good morning, dear participant. Namaste, Gupta sir, and I, Dr. Sunita, welcome Gupta sir and participants and everyone. And okay, okay, okay. So, dear participants, today we have Dr. C.P. Gupta sir. He is eminent speaker, and we all love his teaching pedagogy. He start his teaching pedagogy with the help of soft music, and every time he connect his soft music with theory. So today, the theory he's going to teach, this theory is actually based on bi-directional theory with the help of Granger Causality, logic model, and probit model. And apart from his teaching pedagogy, the way he teach the entire data, software, and analysis and implication, that is really beautiful. So, I'm just going to read his entire brief profile about the academic. Dr. C.P. Gupta, sir, he's a professor of finance in the Department of Financial Studies, University of Delhi, South Campus, New Delhi. He did his MPhil and PhD in the domain of finance from University of Delhi. He worked as a professor in MDI Gurgaon, Dean Faculty, Commerce and Business, University of Delhi. He has rich experience of 40 years of the academic as well as research experience. He has published various research papers in national and international journal. Plus, he has published 3 research books also. He has conducted various training programs which are connected to accounting, finance, and the various training programs he has conducted in the corporate as well as academics. Dr. Gupta, he's consultant with the various projects, even included with our research companies and the government of India. Now, I over to you, Gupta sir, and even this time also he's going to start his presentation with the help of music. Then, and especially the classic music, and really we, especially me and my fellow, after taking his session, we take these kind of music to our study and we start our practice also. So
Uh,
over to you, Gupta sir.
thank you, madam, for the nice
Thank you,
word.
sir.
So, friends, good morning and welcome you. And let's start the day with a lot of positive energy. And That's what you need throughout the day. Lot of concentration, lot of energy, lot of excitement, everything you need. And hopefully this positive energy will be with us throughout the day. Okay. So today is the day of optimism, day full of energy and day full of learning. And you will have a wonderful day which is full of learning, and that I wish all of you. Okay, have a nice time. First, something to think before we proceed further. It says science of econometrics never proves anything. It only disproves or fails to disprove. So mostly what we do, we work with the null hypothesis. We start with the null hypothesis. Either we disprove it or we fail to disprove it. We don't do anything else except this. And that what this quotation says, science of econometrics never proves anything. It only disproves or fails to disprove. Okay, that's very important message for us as a researcher, as a teacher. You must have discussed a lot about time series in earlier sessions. If you have any doubt, any question, you're most welcome before we proceed further. Any one of you, any doubt, any query, you're most welcome for it. It's a small group, 20 participants, and you can unmute yourself if you have any doubt, any question, you are most welcome for it. And make it a point. In these sessions, you will understand, and you will understand. And again, I'm repeating, you will understand, because understanding is very, very important. If you understand, you are confident. If you are not understanding the things, you're not confident about it. The moment you start understanding the things, you start visualizing the what's happening in that particular topic or that particular area. So please make sure that whatever we are discussing in these sessions, you are understanding it. And please don't hesitate in asking me any question, any query, any doubt, whatever you have. Either you can unmute yourself and talk to me, or you can put your query in the chat box. But make sure that you understand. Okay? All right. So any question now before we proceed further? Hmm? Anyone having any doubt, any query about whatever you have discussed earlier? Please let me know. Okay, no question. So friends, let's proceed further. And this time we are moving from, so far so good. And this time we are moving from, univariate time series to multivariate time series. Okay, so moving it from the word of univariate word to the multivariate word. So today we are not going to concentrate only on one time series. We will be concentrating on more than one time series. Okay. Just a question to all the participants. Why do we need multiple time? Why do we need multiple time series? Hmm? why you need multiple. Sachin, you can also answer, no problem.
Yes, sir.
What is the need? Why should I go for multiple time series? What's the advantage? Anyone? Multiple time series allows you to study cause and effect, which are not possible if you are having only one series. If you have one series, then you miss this study of cause and effect. If you really want to see what is the cause, what is the effect, you have to move from one time series to multiple time series. And that's the motivation for me to move from univariate to multivariate time series. Okay, so we are moving from one time series to multiple time series. So now we will be dealing with a number of time series examination. And why should we move from univariate time series analysis to multivariate time series analysis? Because we believe that everything depends on everything else. So when you say everything depends on everything else, that means we are talking somewhere between cause and effect relationship. There are interdependencies which can be exploited from generating information to have better forecast, better estimates, and establishing better relationship. So if you have one series, your information is limited. But if you add other series, your set of information increases. And when you have more information with you, then you can have better forecasts, you can have better estimates, you can have better relationships between the variables which you are studying. I just want to know, any one of you working with time series? Alka, Arjun, Ashwini, Devi, Dr. Elder, Dr. Krishna, Nitki, Madhu, Mukesh. Any one of you working with the time series or worked with the time series? But my motivation is very clear. I'm moving from univariate model to multivariate model to study, you know, cause and effect relationship and to get more and more information to come out with good results. So motivation is exploit the information in other series, and that is what takes me from one time series to more than one time series. Once we have multiple time series, then the challenge is how to model them. That's the challenge which we are facing. Muzibur Rahman is saying is not working with time series. Anybody else? Sunita Ramchandani, if I'm able to pronounce it properly. Triveni, Neha Kumar, all these participants. None of you is working with time series. That's strange. Okay, coming back to the question, how do we model it? Okay, how many of you are from finance background? None is responding. Sachin, who is from finance background?
Sir, as far as we know, many of them are from finance background.
Okay, Pratik Tripathi said yes. Dr. Krishna Murari says yes. Okay, right. So those who are from finance background, tell me any two time series whose relationship they would like to study. Any two time series you give me. Mr. Pratik, can you give me any two time series name? Dr. Krishna Murari.
Sir, good morning, sir.
Good morning.
Example which I would like to quote is like the stock market developments or the financial developments.
Okay.
Whether is it causing the economic growth, financial sector development, especially like maybe
Okay.
the banking sector development, or maybe some other kind of infrastructure development. All these
Right.
kind of developments, if
Right.
we take into
So
account,
okay.
see
Okay.
if they
Right. That's
have any
right.
impact on the economic growth, that would be
Okay. Okay. So what is that indicator of stock market development?
stock Sensex
Okay.
movements in the Sensex.
Okay. 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 So you have one series of Sensex and you have the other series of GDP, right? Okay, I'm not taking other variables, I'm just taking two variables, right? To make the example simple. So what is the model you would like to have here? Yes, Mr. Kishan Kumar.
GDP as a dependent variable, and the
That means you
movements.
would like to study something like this?
Yes, yes, sir.
Okay, so you believe that Sensex is causing a change in the GDP, right? That's what you believe. And then we will put it on test and check through data whether this is correct or this is not correct. Okay, that means what? Once you get the time series in your hand, you have to think what you have to do with that particular time series. And for example, in this case, Dr. Krishan Kumar said Sensex and GDP, and that's the module. Fine. Now the challenge is how to estimate this model. Okay, any other example? Anybody else like to give? Mr. Tripathi?
Excuse me, sir.
Tesla versus India GDP.
Hello.
Right.
Hello.
Mr. Pratik is saying Tesla versus India's GDP. I don't know what he meant by Tesla.
Hello.
Tesla is a company. Yes.
Good morning, sir.
Good morning, Dr. Elder.
Sir, I think Sensex is the function of the GDP. GDP is
Okay.
not the function of the Sensex.
Okay. Okay. I'm not going into the theoretical discussion. What is causing what?
Yes.
That's what we are going to discuss now. Okay. But someone is having some idea about the cause and effect relationship. Okay. So inflation versus money supply, right? So you have inflation series and you have the money supply series. Okay. So Mr. Rahman, tell me, is it the inflation which is a function of money supply, or is it the money supply which is the function of inflation? Both are interdependent. Whether the inflation causing money supply, or is it the money supply which is causing inflation, or do you have bidirectional relationship? Money supply causing inflation, right? So you believe that it is the money supply which is the cause, and inflation is an effect. Okay. Now I take all of you to a philosophical question. How do we know what is cause, what is effect? How we come to know that it is the cause or it is the effect? Do we have some formal definition of a cause or of an effect? Tesla review growth versus India's GDP growth. Okay, so you have the Tesla's review growth. I don't know what you mean by review growth. I am looking for a number. Are you talking about the Tesla, you know, company which is showing the growth in its revenue or GDP? I don't know what exactly Mr. Prateek you want to say. Okay, I'm happy that you people started thinking of once you have the time series data with you, how to model them. And we have multivariate time series data with us, with what approach we should go ahead to model the time series data. And we have two approaches. One is called bottom-up approach and another is called top-down approach. Okay. So I take example of Sensex and GDP. I start with an assumption that both are independent. Okay, so I assume that no relationship exists between these two series. They are independent of each other, no relation between them. Put it on test. And then see whether assumption is wrong. And if the assumption is wrong, then you prove dependence. This is one kind of approach you can see. Start with the assumption, no relation. Okay? Put it on test and check and prove later on that there is a dependence. There is another approach. Start with the assumption that both are related. There is a relation between them. Okay, start with that assumption that both are related. Put it on test and then prove that they are not related. I hope these approaches are clear to you. One is called the bottom-up approach, another is called the top-down approach. And these two approaches you can adopt to check and to prove or disprove your, cause and effect relationship, dependent and independent relationship among the variables. Okay, so bottom-up approach in this, we first assume data generating process of the different time series are independent of each other. Then we ask whether some specific time series are related to each other. So put it on test and then prove whether they are related or not. So if you are following this approach, then this is the approach which was propagated by Mr. Granger and employed when we talk about Granger Causality test. Okay, and that's the focus of this session, Granger Causality. Another approach, So first you assume data generating process are independent, and then we put it on test. If we reject null hypothesis of independence, we establish dependence. That's what we do in a bottom-up approach. On the other hand, in the top-down approach, we assume that the generating processes are not independent, which means they are dependent. And then we use the data to test it, and then we say whether the data processing is independent or not. This approach is pursued when we use a vector autoregressive process or VAR. Both approaches are employed to investigate the causal relationship which potentially exists between different time series. Okay. So we assume that data generating process of the different time series are dependent, and then we prove they are independent. Okay, so I hope these two approaches are clear in your mind with what assumption you start. And accordingly, you are following a particular approach. Bottom up, bottom down approach, bottom up approach, you are assuming dependency and finally proving independency. Okay, that is the approach followed by Granger causality test. Top-down approach, we assume dependency and then we move to independency of the data, independence of the variables. And this is the approach which is widely used in vector autoregression or VAR. Okay, any question? So first, friends, we will take a bottom-up approach. Okay. For all our fight, all fight is to know which the cause of something about which we are doing the research. Everything is a cause, and the cause of anything is everything. But how do we identify that cause? How do we say that is a cause? That's the question which we follow. Okay, Sachin, what is forward and spot?
Forward is all about future trading, and a spot is all about current market, current trading.
Okay, are they related?
Yes.
Yes, they are related. Which is the cause of what?
Theoretically, a spot is affecting future,
Okay,
but practically in market, the future volume is also affecting the spot prices.
okay. So you mean to say forward is impacting spot, right?
Yes.
Now the question is, what does it mean? When you say forward is impacting spot, what does it mean? क्या
Forward
मतलब है
becomes
इसका?
cause and spot becomes effect.
इसका मतलब क्या होगा? On what basis you are saying forward is a cause? How do we say that forward is a cause?
So we assume that forward is a preceding phenomena which is actually having some influence on the spot prices.
You presume, right? That's your assumption. What makes you to make that assumption? Okay. Suppose government says we are increasing commodity transaction tax, CTT. What will happen in the markets? And suppose these are the forward rate and the spot rates of commodity. Yes, Dr. Krishan Kumar, what will happen in that case?
You mean to say this commodity transaction tax is imposed on this forward market in this
It's
case?
already there, but I'm saying it has gone up. Say 50% increase in commodity transaction tax. So what will happen? Nothing?
It will also have some impact on the spot prices as well.
And what about forward?
Also,
What about
forward price.
forward? Forward also, right? You mean to say the commodity transaction effect will have effect on both? Okay, isn't it? But how to prove or disprove it? That's the question which we have. Anyway, that's something we have to understand, and that's the you know topic of this session discussion. And everything has a cause, and the cause of anything is everything. That's what is said. Okay, now let's look at this video clip. Now, as a researcher, we have a question here. Is it fall in temperature that causes snowfall, or is it snowfall that causes temperature to fall? How do we? Hmm? What is the cause? What is the effect here? Is it a fall in temperature that is causing snowfall? Or is it the snowfall that causes temperature to fall? First presumption. Pratik, Pratik ji, what do you mean by first presumption? That means a fall in temperature causes snowfall? But we in Delhi, we in Delhi, whenever we hear that Shimla is having snowfall, Uttarakhand is having snowfall, okay, we started having a temperature, going down in Delhi. So the snowfall somewhere leads to the fall in the temperature in Delhi. देखिए, what you will say about that? कश्मीर में बर्फ हुई, हिमाचल में बर्फ पड़ी, उत्तराखंड में बर्फ पड़ी, दिल्ली में ठंड शुरू हो गई. How you'll react to that? Of course, Pratik ji, you are right. Many people will believe that it's the fall in temperature that causes snowfall. But there might be some people who believes that it is the snowfall that causes temperature to fall. Pratik is considering a isolated system. Yes. So when I'm studying the relationship, you have to define your framework. Are you working in the integrated system or in a isolated system? Okay, right. So what does it mean basically? Deciding cause and effect is not that simple task. What is cause for some may not be cause for the others. What is effect for someone may not be the effect of the others. And that is something which we have to appreciate through this particular example. Let me take another example. Enjoy this lightning and thunder.
Hailing, it's raining hard, lightning all over the place, high winds. Oh!
Okay. Is it lightning that causes thunder, or is it thunder that causes lightning? Yes. Anybody? Or something else causes. Something else causes lightning and thunder. How do you feel about it? Hmm? सोचो, तुम लोग दिमाग तो लगाना पड़ेगा. Only then you will get clarity of the things and understanding of the things. If you stop thinking, you will stop learning also. So you have to think and find out why this is happening. Okay. प्रतीक जी बहुत फिलोसफिकल हो गए आप. So we really don't know. That's a mystery. We don't know whether it is the life that shapes us or it is the our action that shapes life. And you will find we have people who are believing in one or the other. There are people say that what you do, you are, and there are people who says that you are because of your, you know, your fortune and because of the, your fate and other things. Anyway, that's a philosophical thing. Okay, सचिन एक इम्पॉर्टेंट ऑब्जर्वेशन है मार्केट में. अगर रिलायंस का शेयर ऊपर उठता है तो काफी कंपनियों के शेयर्स ऊपर उठते हैं. Many share prices goes up. Can I say it is the reliance that is causing increase in prices of the other shares? Can I say that?
No, sir. It is not necessarily. It may not be necessarily because it's all market psychology, investor psychology, which determines this share price.
Okay. So what does it mean? The
It
cause
may not
might
be.
be
It may not be completely true, but as you said that we need to put it on test. Let's see, and then we can see.
suppose test says that there is a strong relationship. Then
Theoretically, we have to assume. We have to then consider that is it means this is the Reliance share, which it is the price of the Reliance share which causes the upward movement in the other prices of other shares.
okay. How you will prove with data?
Obviously, sir, we have to get the data and then the test of this hypothesis.
Suppose I take LNT share, right? So can I say LNT is equal to alpha plus beta RIL plus error term? Can I say that?
Right, sir.
Beta is coming to be significant. Then can you say Reliance impacts your LNT? Hmm? Can you say that? I mean, we have to be very careful what we mean when we say cause and what is the effect. Unless and until you appreciate that concept of cause and effect, you may not be able to appreciate Granger causality. And I'm devoting a little more time on this idea because I have seen many people have a lot of misconception about Granger causality. And that misconception has to be removed. Okay. Let's see what is the mystery behind cause and effect. When one event causes another to happen, then cause is something what is called why, and effect is what happens. A cause should create a new thing or change the existing thing or a system. So if I say X is my cause, so change in X should result in change in Y. So if change in X is not changing my Y, then X cannot be the cause of Y. Causality in one thing, the cause, under certain conditions give rise to or causes something else, effect. The essence of causality is generation and determination of one phenomena by the other. Cause always precedes effect. Past events are causes of future events, and future events can never be the causes of events in the past. That's how we understand. Past events are causes of future events. Future events can never be the causes of events in the past. लेकिन अगर आप हिंदू माइथोलॉजी में बात करोगे ना, तो कहते हैं आज वो हो रहा है जो फ्यूचर में होने वाला है. राम को वनवास इसलिए मिला क्योंकि रावण का वध करना था. तो वो फ्यूचर में होना था, उसको करने के लिए आज मैं कर रहा हूं कुछ. So many times, if you want to have something in future, you start doing it today. तो जो फ्यूचर में होने वाला है वो आज का कॉज बन जाता है कई बार. But that's not scientific way of looking at. Scientifically, we believe that future cannot be the cause of the past. It is the past will always be a cause for the future. Okay? But time series has its own logic of cause and effect, and that's what we have to understand. Variable x would be causal to y if x could be interpreted as cause of y and or y is the effect of x. Okay, so cause is y, effect is what's happened. For cross-sectional data, it is the theory which provides us necessary information about cause and effect relationship. But what about time series analysis? टाइम सीरीज में कॉज एंड इफेक्ट को हम कैसे समझेंगे? और वो जो समझ है और जो क्रॉस सेक्शनल की कॉज एंड इफेक्ट की जो समझ है उसमें क्या फर्क है? बताइए क्या फर्क आपको लगता है? कुछ फर्क नजर आता है आपको? In cross section there is no concept of past and future. Everything is happening at the same time. But in the time series, you have a past, you have a future. अब आप इसको फील करो कि दोनों की कॉज इफेक्ट की जो डेफिनेशन है क्रॉस सेक्शनल के लिए और टाइम सीरीज के लिए, उसमें क्या फर्क होगा बेसिक?
सर in cross section, the variables are actually assumed to be independent of each other, but in series, the variable itself may not be independent with the past values, because it may be related with the past values.
Dr. Krishna, if you say in cross section we assume variables are independent, you will never get a regression model.
Independent variables have to be uncorrelated with each other.
But
Uh,
when we say cause and effect, तो कोई y होगा, कोई x होगा.
but they have to be related with the dependent variable in order to avoid that multicollinearity.
वो ठीक है, मल्टीकुलरिटी वगैरह
issue
की
that
प्रॉब्लम वो एस्टिमेशन की प्रॉब्लम है मेरी. कंसेप्ट लेवल पे बताओ कॉज एंड इफेक्ट का जो फीलिंग है क्रॉस सेक्शन में वो फर्क है कि नहीं है. सचिन, डू यू हैव एनी पार्टिसिपेंट हु डजंट अंडरस्टैंड हिंदी?
I think no, sir. All the participants are comfortable with Hindi also.
Okay. Yes, Dr. Kishan Kumar. Sorry, Krishna Murari, right. Yes, Dr. Krishna Murari. In cross-sectional data, also you have Y, you have X, you have dependent, you have independent. But the way you understand cause and effect in the cross-section, in the same way you cannot understand cause and effect in the time series. सचिन, क्या लगता है क्या फर्क होगा दोनों की डेफिनेशन में कॉज इफेक्ट की? तो वो कहाँ से आ रही है डेफिनेशन?
So better you answer it only.
Anybody else?
So maybe because of the interdependency of the values in time series, that we may explore the causality, but in cross section, actually said there are multiple independent variables, so they need not to be correlated, but the independent.
Dr. Krishna, in time series also, you may have 10 time series, 10 independent variable. That might be possible. So that's not the question.
Sir, may I answer?
Yes.
Maybe, sir, in the time series, there is a sequence of data. There is a sequence of time series data.
Right.
And in cross-sectional data, we have data at a point of time.
Right.
So that may be a difference between time series and cross-sectional.
उससे कंसेप्ट में क्या फर्क पड़ेगा कॉज एंड इफेक्ट के?
सर, पॉइंट ऑफ टाइम पे देखेंगे तो मतलब रिलेशनशिप.
देखिए, एक डेफिनेशन है कॉज पहले होता है, इफेक्ट बाद में होता है.
जी.
क्या वो डेफिनेशन क्रॉस सेक्शन में लगेगी?
कॉज पहले होता है और इफेक्ट बाद में होता है.
ये तो आप मानोगे ना?
जी सर, जी.
मतलब कॉज हो सकता है 1 सेकंड पहले हो, 10 सेकंड पहले हो, या 1 दिन पहले हो, उसका इफेक्ट बाद में आएगा. क्रॉस सेक्शन में तो ऐसा कोई टाइम सीरीज है ही नहीं.
हाँ, तो वो पॉइंट ऑफ टाइम पे होगा तो वो वहां पर नहीं आएगा.
तो फिर वहां पे डेफिनेशन क्या होगी कॉज एंड इफेक्ट की?
सर, दो वेरिएबल को एट ए टाइम स्टडी करेंगे.
मैडम, आई एम हैप्पी दैट यू आर एबल टू थिंक अबाउट इट. Right now, I'm not giving you the answer, but gradually we will understand it. लेकिन आपको ये अप्रिशिएशन हो गया है कि दोनों में कॉज इफेक्ट का जो कंसेप्ट होगा वो सेम नहीं होगा.
जी.
वो थोड़ा फर्क होगा.
ओके सर.
ये अप्रिशिएशन हुआ कि नहीं हुआ?
जी जी सर.
वेरी गुड. In case of time series, we define causality in terms of what is called Granger causality. For time series, we take information from the concept of Granger causality for determining causality. Now let's see what Granger causality means. The concept is based on the premise that cause always precedes effect. It means the concept of Granger causality is related to the idea of succession in time. It means that on a timeline, suppose this is my timeline, and an event X happens before Y, then we can say that X Granger causes Y. And please emphasize this word. I'm saying X Granger causes Y. I'm not saying X causes Y. What I'm saying is X Granger causes time. It simply means X Y से पहले हुआ है. That's it. उसकी वजह से हुआ है नहीं हुआ मुझे नहीं मालूम. Okay, if I take you that example of lightning and thundering, the event which we observe of lightning happens before the event of thunder. Then I will say lightning Granger causes thunder. Meaning thereby that lightning we see first and thunder we say later. मैं ये नहीं कह रहा कि lightning की वजह से thunder हुआ. What I am saying is lightning happens before thunder. Actually, if you remember in the atmosphere, if you see the clouds with positive charge and the negative charge, when they come together, the lightning and thunder are generated. Okay, but in the context of time series, in the context of the meaning of the Granger causality, if I say X Granger causes Y, it means X happens before, Y happens later. सचिन, अब मुझे बताओ कि फॉरवर्ड का इम्पैक्ट स्पॉट पे किस तरह का इम्पैक्ट है? कॉज इफेक्ट है या ग्रेंजर कॉजालिटी है?
ग्रेंजर कॉजालिटी,
क्योंकि फॉरवर्ड में चेंज पहले होता है,
राइट,
उसके बाद चेंज स्पॉट में होता है.
राइट.
So taking you back that example, CTT has gone up. First, it will have impact in the forward. So first we will see change here. See change here, and then we see the change in spot. Then we say that the forward is Granger causing spot. Causes increase in CTT, लेकिन यहाँ पे इम्पैक्ट पहले आया, यहाँ इम्पैक्ट बाद में आया. फॉरवर्ड की वजह से स्पॉट चेंज नहीं हुआ है, चेंज तो सीटीटी की वजह से हुआ है, लेकिन यहाँ पहले चेंज हो गया या बाद में चेंज हो गया. That is something which you have to appreciate. If XT improves the forecast performance of YT, then XT Granger causes YT. If XT does not improve the forecasting performance of YT, then XT does not Granger cause YT. यानी X में कुछ ऐसे इंफॉर्मेशन छुपी हुई है जो YT को बेटर प्रेडिक्ट करती है. So because of that, we say XT Granger causes YT. So for example, if past values of X help to explain Y, then X Granger causes Y. It's a statistical concept that you have to understand. It's not a theoretical concept, it's a statistical concept. Statistically, we are proving or disproving. A lack of Granger causality does not imply that there is no causal relationship. Say, for example, here, if I make the forecast of the reliance, okay, without using anything, I get my mean error this much. And if I use Sensex, then my forecast improves, my error goes down. Then I will say Sensex Granger causes okay. Please note, Granger causality is a probabilistic way of knowing causality. It uses empirical data sets to find pattern of correlation. Granger causality may be related to the idea of cause and effect. I'm using the term may be related, but it does not necessarily mean cause and effect relationship. What can we know from Granger causality is whether a particular variable comes before another in time series. That's the only thing you can come to know. It only suggests precedence of one variable over the other. Okay, so I hope you have got understanding about the concept of Granger causality. Any one of you have any question about this concept? Then our next challenge will be how to, test this idea of Granger causality. Anyone, any questions? Mr. Rahman, any question if you have? प्रतीक जी कोई क्वेश्चन आपके मन में? डॉक्टर हल्दर, भानु प्रताप सिंह, सचिन ये भानु कौन है?
पार्टिसिपेंट है सर.
कहाँ से है?
No sir, we have to check it. कहाँ के हैं?
भानु, are you there?
He's from sir DAVB Indore.
इसने FPM इंदौर से किया है क्या?
No.
अच्छा, कोई और होगा। ठीक है। Okay, so right, so everything now gets clarity. So once we are clear with it, let's go further. Okay, so future values of Y can be better predicted. That is, with a small forecast error variance if the current and past values of X are used. Future values of Y, Yt plus 1 can be better predicted if the future values of this is used in addition to the current and past values of X. Then we say instantaneous Granger causality. And if X is Granger causing Y and Y is Granger causing X, Then we have feedback. So there's a feedback between x and y if x is causal to y and y is causal to x. Okay. So now having understood this concept, let's apply the idea of Granger causality check and see how do we do it in EBS. And when you go for Granger causality test, you have to ensure that the series is stationary series. Okay. Let me take some file. Suppose I take future and spot. So what is that? First we have to check. Sorry. I again open this foreign data file. Sachin, these are the files which I shared with you last time. You can.
Okay, sir. We are forwarding to all the participants.
Okay. I don't know why it is coming. Yes. So let's check whether they have a unit root or not. What does it mean? The series is not a stationary series. So we have to check it at difference. And now the series is stationary. So series will be stationary at the difference. Okay. And then let me check the other one, the spot. If you want a graph of it, you can have a graph of it. Friends, I have a question here because many times, I get some, I see some misconception among the students regarding log. अगर मैं इसका log spot का ग्राफ बनाऊं तो क्या लगता है उसकी शेप में क्या फर्क आएगा? अगर मैं log ऑफ स्पॉट का डायग्राम बनाऊं तो क्या चेंज होगा बताइए? कुछ फर्क पड़ेगा? क्या फर्क पड़ेगा? कुछ तुम लोग बोलते ही नहीं हो। लॉग लेने से आपके ग्राफ में कुछ फर्क पड़ता है? Because many times people say अगर आपको ये प्रॉब्लम आ रही है लॉग ले लो खत्म हो जाएगी. Might tend to stationary. That's what Pratik is saying. Anybody else like to join?
Mean will be constant.
Mean will be constant. Okay.
So the values will be normally distributed.
Okay. Let me freeze this up. That the graph which we have here, I take a log of it. आप मुझे बताओ दोनों ग्राफ में आपको कुछ नजर आ रहा है डिफरेंस? दोनों ग्राफ में कोई डिफरेंस आ रहा है आपको नजर? और सचिन मीन कैसे कांस्टेंट हो जाएगा लॉग लेने से? और डिस्ट्रीब्यूशन कैसे नॉर्मल हो जाएगा? And this is not related to spot. It's related to any series, cross sectional or your the time series, anything. कोई फर्क नहीं होता इनके शेप में. Dr. Rahman, I think you are right. Variance will come down. Variance will come down because the scale is toned down. So if you see here, the scale is 6.8, 7.2 here. This is in thousands. So because of the scaling effect, the variance will be reduced, but not other way around. So it's basically scaling effect. Basic properties of the distribution will not change. Anyway, that's a different question because many of the time I heard from the people कि log ले लो, heteroscedasticity की problem खत्म, autocorrelation की problem खत्म, normal distribution हो जाएगा. ऐसा जरूरी नहीं है क्योंकि सीरीज की बेसिक शेप में कोई चेंज नहीं आता है. And variance mean will be of course lower because of the scaling down effect और कुछ नहीं है. ठीक है? Anyway, so how to make the series stationary? How to make series stationary? बताइए. Series stationary. हाँ?
By differencing.
Simple difference, log difference.
Simple difference will also do now in this case.
Which one is better? Dr. Krishna, which one will be better?
Sir, as you said that log differencing will only scale down the values. So either way we can go ahead with.
No. I said by taking log you are scaling down. I didn't talk about difference. I didn't talk about it. Pratik ji is saying log difference would be good. तो प्रतीक जी क्यों अच्छा रहेगा? क्या रीजन है उसका? If you take log difference, log of P1 minus log of P0, that's equal to log of ये क्या इंडिकेट कर रहा है? if you take a difference of P minus P0, क्या फर्क है दोनों में? This is your simple difference. This is your log difference. What is the difference we see in it? This is absolute. That means if you are working with the prices, this result will be in terms of rupees. This is dimensionless. And will give you idea about continuous return. So log difference has a very specific meaning in finance. So if we have to take a difference, normally we go for log difference. And that's the reason for it. It gives you better because it's dimensionless. It's the result is coming in terms of the fractions or the percentage, and it represents continuous return, which is having a very specific interpretation. So we ignore simple difference. We will go for the log difference. For that, we have to create a series. So quick generate series. So I say log difference future is equal to log of future divided by future that the command we are using. So I'm generating the series of log difference of the future. Okay. Similarly, we define a series for spot. So I take here instead of future, I define a spot. So we have a spot here and we have a spot here. Okay. So two series are being generated, then we say okay. So I take these two series, open as group, then go to view, Granger Causality test. What does it say? Spot does not Granger cause this? Not rejected. Future does not Granger cause spot? Rejected. That means the future series is Granger causing spot. Now, what is the interpretation of it? ये सिर्फ यही कहता है कि फ्यूचर में चेंज पहले आती है, उसके बाद चेंज होता है स्पॉट। दिस इज द ओनली थिंग इट सेज। स्पॉट में चेंज पहले नहीं आती है, स्पॉट में चेंज बाद में आता है, और फिर फ्यूचर में सॉरी स्पॉट में चेंज बाद में आती है, इसलिए फ्यूचर पे उसका इम्पैक्ट नहीं आता है। फ्यूचर का इम्पैक्ट पहले आता है, फ्यूचर में चेंज पहले आती है, इसका इम्पैक्ट फ्यूचर में आता है। Okay, any question here? Let me take another example and see how we can do it quickly. I tell you, testing doesn't take much time. What takes time is the understanding of the concepts. Suppose I take Nifty prices. These are the Nifty futures and Nifty spots. Okay, so if you click on it, you will find the sorry view graph, and you will find the series is not a stationary series. You can also check it. Unit root, level. The series is not a stationary series. And most of the time, friends, you will find economics and finance, most of the series are non-stationary at the level. But by taking their differences, you can make them series, you can make them stationary. So I do it quickly and generate series. Suppose I take a D of future, that's equal to log of future futures divided by futures minus 1. And similarly, we can define another series about the spot. D spot is equal to log of the spot divided by the spot minus 1. Then I open up these two series together as a group, Granger Causality. What does it mean? क्या शो कर रहा है ये?
No one is Granger causing to each other.
What does it mean?
Neither spot is a Granger causing to future.
क्यों ऐसा क्यों हो रहा है? निफ्टी में हो रहा है, यानी एनएससी में हो रहा है, कमोडिटी मार्केट में नहीं हो रहा। कोई बता सकता है? अरे रिजल्ट निकालना जरूरी नहीं है, इसको बताओ तो सही ऐसे क्यों हो रहा है। एनएससी में स्पॉट का फ्यूचर का कोई ग्रेंजर कॉजैलिटी नहीं है, कमोडिटी मार्केट में है, ऐसे क्यों है? प्रतीक जी आप ही बताइए, हल्दर जी आप बताइए। एनएससी में नहीं है, कमोडिटी मार्केट में है, इसका क्या मतलब है?
Because maybe commodity market, there is no spot exchange.
ओके, हाँ सचिन ठीक कह रहे हो, आगे चलो, पूरा करो आर्गुमेंट को।
And therefore, it is not affecting a future. Grains are causing future. No.
स्पॉट को तो कर रहा है ना। अरे एनएससी में फ्यूचर और स्पॉट साइमल्टेनियसली ट्रेड हो रहे हैं,
Right.
तो जैसे एक में चेंज हो जाता है ना तो इमीडिएटली दूसरे में चेंज आ जाता है। एंड दिस इज ऑल डेली डेटा विच आई एम शेयरिंग विद यू इज अ डेली डेटा। अगर आप मिनट टू मिनट डेटा लें या हाई फ्रीक्वेंसी डेटा लें तो हो सकता है कि कुछ ग्रेंजर कॉज उसमें नजर आए, लेकिन एक दिन में नजर नहीं आता, एक दिन में सारी चेंजेस एडजस्ट हो जाती हैं। कमोडिटी मार्केट में एज यू सचिन सेड, स्पॉट की मार्केट नहीं होती है, जैसे ऑर्गेनाइज्ड फ्यूचर मार्केट है या फॉरवर्ड मार्केट है। तो ऑर्गेनाइज्ड एक्सचेंज में इम्पैक्ट पहले आता है और उसका इम्पैक्ट नेक्स्ट डे या थोड़े दिन बाद स्पॉट पे नजर आता है। एनएससी में तो इमीडिएटली नजर आ जाता है इम्पैक्ट आपको। ठीक है,
Right, sir.
आई होप you have understood the concept. You have also understood the concept how to do it in the EPS. Once we determine the dependence among variables through Granger causality, you can develop a suitable model for your purposes. The second approach is a top-down approach, and that is discussed under your vector autoregression model. सचिन वार पे हमारा सेपरेट सेशन है कि नहीं है?
No, sir.
है?
No. We have not scheduled any specific session on bar.
ठीक है. So friends, let's start with the simple thing. I have two data sets with me, y1 and y2. Okay, and I take only one data, right? And assuming ARIMA 1, so y1 t is a function of alpha plus beta 1 1 y1 t minus 1 plus beta 1 2 x. Then we are studying the Granger causality between x and y. क्या assume कर रहे हैं इस इक्वेशन में? When I developed this equation, what was my assumption? कि x और y में कोई रिलेशनशिप है कि नहीं? And then I will test whether my beta 1 2 is equal to 0 or not. If it is equal to 0, then I will prove they are independent. Otherwise, they are dependent. See the difference in the approach. Okay. Another equation is y2 is equal to alpha plus, sorry, x नहीं है ये, this is not x, या मैं यहाँ पे x ले लेता हूँ, x I take here y2 beta 1 t1 y2 t minus beta. Right? Now look at these coefficients. If you prove that beta 1 2 is equal to 0 is equal to beta 2 2, अब क्या प्रूव कर रहे हो? अब क्या प्रूव कर रहे हो? None is Granger causing the other one. If beta 1 2 is equal to 0 but beta 2 2 is not equal to 0, what does it mean? One is Granger causing second. If both are not equal to 0, what does it mean? A feedback mechanism. That is, y1 is impacting y2 and y2 is also impacting y1. And because of that, the coefficients beta 1, 2, beta 2, 2, they are significantly different from 0. That's the basic philosophy of my vector autoregression model. So you have a vector of the dependent variables, autoregressive. That's how we get this done. Okay, so error term follows normal probability distribution. Covariance between them is this one. And again, you have to ensure that the series are stationary series. So if you have more than two variables, then you can have 1, 2, 2 minus 1, t minus 2. I'm considering lag 2. Similarly, I have 2 lags for the second variable. And my interest is in these coefficients. If all are equal to 0, that means, no one is Granger causing the other. Okay? And for a 2 variable and to this, that's what we get. And accordingly, we go for Granger causality test. Beta 1 1 is equal to beta 1 2 is equal to 0. Similarly, for the other direction, this is the same meaning as our causal word of the causation. The answer is no. Okay, we only say that the lags of a variable helps me in getting better forecast for the other. So what is the purpose of making a war model? Exploit the relationship among the variables to get better forecast and to get better estimates. Okay, so let's say let's use the e-views and see how it works. I take both the I go to estimate what, and my variables are d spot and the future. So go to view, estimate what, unrestricted what, sorry, quick estimate for, unrestricted for, we have D spot and D future. This is spot with the spot. I'm not interested. I'm not interested. Spot with the future. These are the standard errors. This is the t-value less than 1. Future less than 1. What does it mean? Future is not causing, not Granger causing spot. Okay. Here, this is 1.958. This, same conclusion. We also get about the spot. Okay, that's how you can make use of what methodology to come out with the result. Let me take another file to do it quickly before you. Suppose I take gold. So we have the return of the gold future and return of the spot future. Right click as group. And then you can get the Granger Causality test. So spot does not Granger causes future, but future is Granger causing spot. The same thing you can estimate through what? We have RT underscore spot, RT underscore future, and that's the result which we get. Do you see this number? This is t-value, which is minus 2.70. तो बताइए नल एक्सेप्ट होगी रिजेक्ट होगी? सॉरी ये तो फ्यूचर का फ्यूचर पे ही देख रहे हैं, बट वी हैव टू सी द स्पॉट एंड द फ्यूचर. देख रहे हैं आप? स्पॉट पे फ्यूचर का इम्पैक्ट आ रहा है. Both are significant because t value is very high. And here, spot doesn't have impact on the future because p value is very low. That's how you can get this up. Okay? Any question about it? Any doubt? Any query? So trust that you must be feeling comfortable with the concept of Granger causality. If you have any question, any doubt, you're most welcome. Okay? So that's all in this session. Thank you very much for being with me in this session. Thanks a lot. Enjoy. Sachin, आप कितने बजे शुरू करें?
You suggest, sir, 12:15?
Right. ठीक है.
Okay. So dear
Anyone
participants,
having any doubt, any query, even in the break, you can put that query in the chat box. I'd love to answer that. But make sure that you are getting the things, you are getting the grip of the concept which we discussed. Okay?
okay, sir. So dear participants, again we are reassembling at 12:15 sharp.
Sir, are you there?
Should we start?
Yes, sir. Yes, sir. Welcome back, sir.
Thank you. Just a minute.
जी sir.
एक सेकंड.
जी sir.
हाँ मीना जी. हाँ. अच्छा. बस मैंने इसलिए कहा था वो जो भेजे थे. Are you able to hear me?
Yes, sir.
Great. So friends, let's see what we are going to begin with. What comes to mind when you see this? It's a movie which is Hitchcock. Okay, there are certain things which we as a teacher have to learn.
पता है कमाल की बात क्या है? ये चौक को ऊपर से हल्का सा तोड़ दो तो ये चू चू नहीं करती. एक छोटा सा टुकड़ा, एक छोटा सा चेंज, यही फर्क होता है क्यों में और क्यों नहीं.
Please appreciate the difference between why and why not. And the moment you start, appreciating it, as a teacher, as a scholar, you will start understanding the, things in a wider perspective. And that's what we have to understand. Okay. Let's go ahead with our next item of the session. Okay. What next? That's what we are going to discuss. Friends, any quick question if you have for the from the previous session?
Sir, there are some questions in the chat box.
Okay, so Madhuji is asking how do we select or know the lags? So selection of the lag is just trial and error. So you try with 1 or 2 or 3 lakhs. That's more than sufficient, because in most of the cases we believe that market will adjust within a few days. Okay, so that's something which you have to work. And even in the war model, you can play with the lakhs. You experiment with the lakhs, you take different lakhs and then see which gives you the good results. And for comparison results for var, you can compare the information criteria. Okay, but what is the optimum lakh? Nobody can tell you offhand. It depends upon your problem, depends upon your data, and depends upon the relationship. Okay. Madhuji is asking, can we go directly to Granger causality test after checking for stationarity? Once you ensure that series are stationary, you can go for Granger causality test, no problem in that. Madhuji, you can also go for 1 or 2 lakhs if you are working with monthly or yearly data, but you have to understand the relationship. So, for example, growth rate in the GDP may have impact on the you know investment in the next year. Okay, so you can take 1 year lag or the 2 year lags. That depends again on the nature of the problem and the nature of the issues which you are addressing. But if you are working with the share market prices and you take the prices, monthly prices, then I don't think any lag will work, because all the changes happening in a month are adjusted almost instantaneously. Okay, so Madhuji, is that clear? You have still more questions? Anybody else? Okay. So let's see what next we are going to talk about. Have you ever thought that what factors improve the chances of making a merger successful? What increases the probability of making a merger successful? How do we know that? Hmm? Further, have you ever thought that can we increase the probability of making a company more financially sound by increasing its cash from operating activities? Can we do that? Is that possible for us to do? Have you ever thought that what factors make a person to invest in the stock market, or what are the factors which are, discouraging person to make investment in the stock market? Imagine, what if your dependent variable is a binary variable? What will happen in that case? Okay, if I take a generic regression module, y is equal to alpha plus beta 1 x1 plus so on, plus beta k xk plus error term. What's the assumption we have for y? Anybody? Simple regression, cross-sectional regression for simplicity's sake. What is the assumption we have for y? Any one of you?
So y is a predicted
Y is it?
value given the t or
Yes, Dr. Krishna. Y is a predicted variable, right? But that's a feature.
Given that we have the known values of x, y, or
Okay.
xt values.
Okay. Sorry. So if you write y is equal to beta 1 x1 plus so on beta k xk. Okay. Uh, Dr. Krishan Kumar, when you say known values of x, what does it mean? What does it mean?
Values of independent variable are known. We know the values of independent variable to get the values of dependent variable.
But we also know the value of the dependent variable. If you do not know the values of the dependent variables, you cannot run regression.
Point.
Dr. Kishan Kumar, I think there is some problem in your audio and we are not able to hear you properly.
This is for purpose, sir.
Ketki, I will come back to your question. Okay, but let's look at this why. Anybody of you, what's the assumption we have for y? What is the level at which we measure y? What is the level at which we measure y? Any one of you? अरे कुछ तो बोलो तुम लोग. रहमान जी कहाँ पे हो? प्रतीक? See, y is supposed to be measured at a scale level. Please understand that. So when you run a simple regression, we presume that y is being measured at a scale level. But it might be possible that y is not a scale variable, but a binary variable or a categorical variable. Then what should we do? That's the challenge we are going to face. Okay, anybody would like to answer Ketki's question? Can we have independent variables, the categorical variables? Any one of you like to respond? Anyone like to respond? Can we have categorical variables and independent variable? Prateek ji, bolo, Dr. Helder. Hello.
I'm listening your talk, sir.
Just a minute. Hello. Hello.
Good afternoon. Sir.
Hello.
Gupta sir, you are audible.
Hello, sir.
Huh? Madam, who is trying to speak?
Sir
Sir
Devi
Devi
Prasad.
Prashant.
तो मुझे लगता है कि उनके ऑडियो में प्रॉब्लम है ना?
जी सर, उनकी आवाज सही नहीं आ रही है। उनकी तरफ से कुछ प्रॉब्लम है सर नेट में।
ठीक है, ठीक है। मुझे लगा शायद मेरे एंड पे कुछ प्रॉब्लम ना हो।
नहीं सर, आपका आवाज बिल्कुल क्लियर है।
So, yes, independent variables can be categorical variables, and they are independent variables can be categorical variables, and for that we introduce dummy variables. So whenever you find any, the independent variable is categorical variable, you introduce dummy variable in your model. So dummy variable will take care of categorical variables of your problem. Okay? Madam, is that clear? Kitki madam? Yes. Okay. So the problem which we are going to face is, what if my dependent variable becomes binary variable? If my dependent variable becomes binary variable, can you still use OLS? That's my question. If your dependent variable is, the binary variable, can we use OLS?
No, sir. We cannot run OLS, sir. Gupta sir, good afternoon.
Yes, Deviji, good afternoon. Now your voice is clear.
Sir, can you recognize from Odisha?
Yes.
From Odisha, sir.
Namaskar.
Grateful to listen to you, sir.
Okay. Thank you, Deviji. Thank you.
Sir, we cannot run OLS, sir.
Yes, we cannot
A
use
great
it.
pleasure to listen after a long time.
Right. Thank you, Deviji. Thank you.
Sir, we cannot run OLS.
Yes. And if we cannot use OLS, then
we cannot run OLS.
Yes. So if we cannot use OLS, then we need certain tools to work with this problem. And that's where, we need the separate discussion when we have binary dependent variable. And Ketki is saying maximum likelihood method. Yes, that's what we are going to use. But before that, we have to look for something else. So friends, if you come across with a problem where your dependent variable is a binary variable, then you can make use of what is called a linear probability model, logic model, or profit model. And we will first start with linear probability model, then we will move to profit and logic model. Okay. So now we shall talk about a regression model with the dummy, qualitative, binary, or limited value dependent variable. Okay. So we are having a regression model where my dependent variable is a dummy variable taking value 0 and 1. And this takes us to linear probability model, profit model, and the logic model. And first, we shall start with the linear probability model. Okay, so topic for the session is modeling with qualitative and limited dependent variable. Let's consider a problem. A researcher is trying to find out what determines bankruptcy of a firm. He took a sample of 33 solvent firms and 33 bankrupt firms and collected the information on these ratios. Working capital to total asset, retained earning to total asset, return on asset, asset turnover ratio, market value to book value. So developed a model where my group variable is a binary variable. 0 means company is bankrupt and 1 is company is solvent. And we get this model. Okay. What does this equation means? If the estimated value of the dependent variable group is 0.75, and how do we interpret that? In the estimation, when you get the estimation, it's not necessary that your value will be either 0 or 1. Value can be anything. Suppose the value comes as 0.75 for estimated equation. Then how we will interpret this? What does it mean to us? Does it make a sense or does it not making sense? Is it making sense or not making sense? How do we know? Heck yeah, 0.75 catches it. It can be 0.75, it can be 0.35, it can be 0.20, it can be 0.8, it can be anything. How we will interpret this? To appreciate the issue involved in a regression model with binary dependent variable, let's consider a model with one explanatory variable. Yi is equal to alpha plus beta 1 x1 plus error. Okay. Dr. Krishnan Morari, are you able to talk now? Can you speak now? I want to know what you mean by known X because it has a very important significance. Dr. Krishnan, okay. Mr. Rahman, what we mean by somebody, yes, please.
The known values of X means we have the values from the past data.
Okay.
And these values are used to forecast the values of dependent variable.
But we also know
from the past information we have.
We also know the value of Y.
We know the values of Y.
But
in future, we want to know the values of Y.
Okay.
Given the estimates of the estimated parameters of regression alpha and beta for the regression equation, and also with the help of values of X.
I think Dr. Krishnan, you're missing a very important point. When you get the estimate of the Y hat is the estimated value of Y. What is it? It is called expected value of Y given X. Then all of you should understand, whatever estimated values of Y we get for given X. That means I know X which are given to me And given that x, what is the expected value of y? That is my estimated value of y, the y hat. Dr. Kishan Kumar, this is precisely and technically means. You are very close up when you said given x, okay? But I am putting it in a very formal structure. So friends, please understand this point. It's a very important point. The estimated value of y which we get, that's equal to the expected value of y given x. Okay, is that clear? So we have the expected value of y given x, that is my estimated value of y. So expected value of xi given yi given xi is nothing but the expected value of y given xi. Okay, right? So, you know, what is that implies, we have to find out. Given x, your y can take a value either 0 or 1 with corresponding probability, say p for 1. P1 is normally taken as success and 0 is normally taken as a failure. So success is the probability 1 and failure is the probability 1 minus p. Then my expected value will be this into this, that's equal to 0. This into this, that's equal to p. That means expected value of y given x is equal to p. Is that clear? That means if you get a value 0.75, this is the probability that the event is taking value 1. If you get a value 0.80, it is the probability that the event is getting a value 1. Yes, Dr. Halder, you are absolutely right. These are all conditional probabilities given x. Okay, so given x, these are the expected values which we get. Okay, so thus we can say that pi is nothing but the expected value of y given xi, or the estimated value of the equation is my probability value. Okay, so friends, estimated value of this model is nothing but probability model, probabilities. And since it's a linear model, we call it as linear probability model. The probability, the estimated value is interpreted as the probability of having by I as 1. The interpretation of the coefficient of xi is marginal increase in the probability that a particular y takes a value 1 for 1 unit increment. Okay. Suppose I say y is equal to alpha plus beta x plus error term, where y is my binary. then y estimated will be equal to probability, which will be equal to expected value of y given x. Is that clear? Anyone having any doubt? So the result which you get from this estimated model is a probability that your variable is taking value 1. That's how we understand. Okay, and the coefficient value will be a increase in the probability value for increase in 1 unit of x. So y is this is your estimated equation, line of best fit. That's your regression. And for a given x, this is the value y hat, which is equal to this one. This is probability of p. This is 1 minus. That's how we get it. Okay. So this is your estimated y, which is equal to pi. This is 1 minus pi. Does this model create problems for us? Any question before we go ahead, because this is an important thing which you should understand. And I repeat, dependent variable can be binary variable. Okay, and if we estimate it, the estimated values are nothing but the probability value that my variable is taking a value 1. Okay, now the question is it creating problem for me? And this model means the linear probability model. Does it create problem for me? Yes, Rahman, you are saying yes. What problems it creates? That is something which you have to understand. Anybody like to say what problem it creates? It's a linear function. Please understand that. It's a linear function. It will go on increasing. It will go on decreasing. What does it mean? Huh? The probability increases with the value of x, and it could be possible that at times this becomes negative or more than 1. And if it becomes more than 1 or becomes less than 0, then we are not able to interpret them, in a meaningful manner. So the problem which you find from linear probability model is that my values of the probability may be beyond the range of 0 to 1, and that creates a problem. Another problem is the distribution of the error term is not normally distributed. It is binomially distributed. Why is it? because my variable is a binary variable, and binary variable follows a binomial probability distribution. But if we recall, the assumptions of the classical regression model is that error term follows normal probability distribution. But that's not the case here. It's following binomial probability distribution. Second, the error term are not homoscedastic, but they are having a problem of heteroscedasticity. What is the variance of a binomial distribution? Any one of you tell me? What is the variance of the binomial distribution? Any one of you recall? If you remember, this is NPQ, where Q is nothing but 1 minus P. And that means as N increases, variance increases. So my variance doesn't remain constant, it changes. And that creates a problem of heteroscedasticity in our linear probability model. And that is what this point is telling us. Next problem is in the linear probability model, as x increases, the probability value continues to decrease, and it might be possible that you don't get it. Because your linear equation means it is either constantly increasing or constantly decreasing. And that makes a situation where your probability is going beyond the range of 0 to 1. And if it is going like that, you get absurd results. So in that case, what we need some kind of a nonlinear relationship to restrict the probability values between 0 and 1. And how to do it? That's one of the biggest challenges. Suppose I'm measuring x here, p here, and I want all the values should be my probability values will be always between 0 and 1. Now, can you think or imagine what should be the shape of my function so that it always lies between 0 and 1? Of course, it will not be a linear function like this. Any idea what should be the shape so that the values are always in the range of 0 to 1? For whatever value of x you take value of x here, here, anywhere.
Parallel to x-axis?
Pardon? Parallel to x-axis.
Yes,
You
sir.
will associate there?
Yes, sir.
But
No, sir. Yeah. वो minus में चला
it should
जाएगा.
take a value 0, it should take a value 1, and Ketki is saying S shape, right? Ketki, you are right, it should be S shape. That means its shape should be like this, S4. So when x is going towards minus infinity, probability should tend to 0. When x is tending to plus infinity, probability value should tend to 1. And that's the peculiarity of this S-shaped function. So as x is going to infinity, it's going to 0. And x is going to infinity, this will be converging to 1 and it will remain 1. So friends, to avoid, the problem of the linear probability model, we have to look for nonlinear model. And in the class of the nonlinear model, we are looking for models with S-shaped function. Now the question is, what kind of functions are S-shaped functions? If I use any function which is S-shaped, I can make use of it and then work with my problem. But what are those S-shaped functions which I can make use of in my analysis? Ketki, can you tell me any S-shaped function? To limit the values of P within 0 and 1, usually S-shaped relationship is used between X and the probability. And in this regard, we use two S-shaped functions. One is called the logistic function, and another is your normal probability distribution. So one can make use of logistic and standard normal probability distribution. If you are using logistic function, then you get a model which will be logit model. And if you're using a standard normal probability distribution, then you get a model which is called probit model. And friends, if you remember the cumulative standard normal probability distribution will be like this. Here you have Z, here you have the probability. Can any one of you tell me what is this point? For the standard normal probability distribution, cumulative. This will be 0.5. Because at 0, the total probability, the cumulative probability is always 0.5. Okay? And it will be convex here, then it will become concave here, and that's how it becomes. Okay? So by using the logistic function, we obtain a model which is the logit model, and one which is obtained by using a standard normal probability distribution, we get the probit model. Okay? So friends, if you are using a normal probability distribution for estimation purposes, you get probit model. And if you are using the logistic function, that's called the logit model. So let's start with the profit model. So how this looks like. This is your cumulative normal standard probability distribution. Note it's nonlinear and its values will always lie between 0 and 1. And the equation is fz under root 2 pi the and you know standard deviation is 1, so I don't write 1 here. So that's equal to e to the power minus 0.5 z squared. This is the density function, and you want the probability. You have to take the integration of it, and that will give you the area under the curve. So friends, probability you will get as area under the curve, which is nothing but the integration of normal probability density function. Okay, so let me repeat what I'm saying. My probability value will be equal to my probability value of z, which is less than equal to alpha plus beta x. I'm taking only one variable here, okay? And this z is what your z will be the estimated value, which you get alpha plus beta x plus error. So you estimate here, z, plug it here, use normal probability tables to get the probability. That's how we proceed in this case. Okay. And this quantity is called the normal equivalent deviate, or NED, or normant. Now let's see, how do we estimate? We do the estimation by making use of maximum likelihood method. We don't use OLS. And yes, Kitty, when you said we use the maximum likelihood method, you were absolutely right. Okay. I will come back to the EViews and estimation of the profit model. Let, for the time being, discuss the logit model. Logit model assumes that the underlying distribution is a logistic function or sigmoid function, and it is again S-shaped function, like this. And its value always lies between 0 and 1. Logit model expresses the probability P that a dependent variable y takes the value 1 given xi, and that's your sigmoid function. And that's how we get the probability. So friends, what we do, we estimate z, which is equal to alpha plus beta x, and we get the probability, which is equal to 1 over 1 plus e to the power minus alpha plus beta x. So, which is nothing but z. So calculate the value of the z, plug it here, and get the probability. Okay, now a couple of things we have to understand here. 1 over 1 plus e to the power minus z. If z tends to infinity, what happens to the value of p? Hmm? Probability value is 1 over 1 plus e to the power minus z. If z tends to plus infinity, what is the value of the p? If z tends to minus infinity, anyone of you? Right, Rahman is saying when z is tending to infinity, the probability value will be 1. And if z is tending to minus infinity, the probability value will be 0. That means the value of the probability will always lie between 0 and 1. Okay, now you can check it. Z is, plus infinity, minus z e to the power minus z will be a very, 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 very small number, and it will become equivalent to 1. Because it will be 0 in that case, and you get the number 1. On the other hand, if this is minus infinity, so what do you get? 1 plus e to the power plus then numerator will become very, 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 sorry, denominator will become very, very large, and this will tend to 0. So that shows whatever value of the z you are going to get from your estimates, the probability values will always be lying between 0 and 1. Okay? Is that clear? Now the question is, what is this z? Anybody? What is this z? How do we interpret this z? I think a little bit of mathematics, I think you will not mind if I do it. I know that probability of I is equal to 1 over 1 plus e to the power minus z. That's your logistic equation. Okay, now we are trying to understand what is this z, what this z means. ये z है क्या? इसका interpretation क्या है z का? So we get 1 plus e to the power minus z, that's equal to 1 over p e to the power minus z is equal to 1 over p minus 1, which is equal to p sorry. One minus p, which means e to the power z is equal to p over 1 minus p. right? Which means if you take log of both these sides, okay, so Z is equal to log of P over 1 minus P. That's my get. Okay. I have a question here. What is this number called? P over 1 minus P. Suppose if you throw a coin, what is the probability of success? The head, 50%. Probability of tail is also 50%. So I get 0.5 over 0.5. 1. Okay. If you throw a dice, what is the probability of getting an even number? Sorry, what is the probability of getting 1 or 2? So you will say this is 2 by 6. Not getting is 4 by 6. What we get here is 1 by 2. What these numbers represent? Any one of you? This 1 minus P upon P is called odd ratio. Sorry. P over 1 minus P is called odd ratio. This one. This concept of 1 by 3. Dr. Halder, how do you get this 1 by 3?
Sir, as you said that what is the probability of getting 1 or 2? So 1 divided 1 by 6 plus again 1 by 6, that is 2 by 3.
2 by 6, what you are saying 1 by 3. Okay. That you are saying, right?
Yes, yes. 2 by 6, that is the 1 by 3.
Okay. And this is 2 by 3. So 3 get cancelled and we get 1 by 2. What is the meaning of the odd ratio? If I say my odd ratio is 2, what does it mean? Anybody?
Hello.
Yes, Dr. Halder.
सर ये जो आपने 4 by 6 लिखा है इसमें इसका मतलब क्या हुआ? ये 4 नंबर है ना, ओनली दिस इज ओनली नंबर 4 ना?
4 by 6 का ये probability है
गेटिंग 4 ओनली ना?
है?
गेटिंग 4 ओनली ना?
No. Getting not 1 and 2.
सर नॉट 1 and
2.
यस, तो फिर रिमेनिंग इज 4. यस,
तो हो गया 3, 4, 5, 6. तो 4 by 6.
थैंक यू सर.
डॉक्टर हल्दर मुझे बताइए, अगर ऑड रेशियो 2 है तो इसका क्या इंटरप्रिटेशन होगा?
सर सॉरी सर, ऑड रेशियो के बारे में मुझे पूरा रिकॉल कर लिया मैंने, जहाँ तक तो मुझे ऑड रेशियो मैंने अभी तक कहीं पढ़ा नहीं सका. Odd ratio मुझे
Rahman is saying probability of success is 2 times failure, right? Yes, Rahman, you are absolutely right. Odd ratio means if you get an odd ratio of 2, that means success is twice as likely as failure. If you have odd ratio of 3, sorry, your odd ratio is defined as P over 1 minus P. If you say it is 3, that means success is 3 times more likely than the failure. That's the meaning of it. Or if you say odd ratio is, say, 1 by 2, what does it mean? Failure is twice likely than success. Or chances of success are half of the chances of failure. That's what it means. Is that clear? If somebody is having odd ratio of 5, that means probability of success is equal to 5 times of probability of failure. That's what it means. Dr. Haldar, अब clear हुआ क्या है odd ratio?
Yes, sir. Clear है, sir.
How many times probability of success is over the failure? ठीक है? अगर मैं कहता हूँ सक्सेस जो है 5 टाइम्स है फेलियर का, तो सक्सेस की प्रोबेबिलिटी क्या होगी? सक्सेस की प्रोबेबिलिटी क्या होगी? P is equal to 5 times of 1 minus P, which is equal to 5 minus 5P, which means 6P is equal to 5, P is equal to 5 by 6. So the success is the probability of 5 by 6, and failure is having probability of 1 by 6. That's how we do it. Okay. So if you say the odd ratio is 1, so 1 is to 1 success and failure. So the probability of success will be 1 by 2, failure 1 by 2. That's how you can get it. So you take the total of it, 1 divided by 2, 1 divided by 2. If the odds are like 5 is to 1, probability will be 5 by 6, 1 by 6. If the odds are, say, 6 is to 1, probability will be 6 by 7 and 1 by 7. So that's the connect between the odd ratio and probability. And when we work with the logic model, many times you will come across with this terminology of odd ratio. So friends, now from this discussion, you are able to understand what is an odd ratio. Is that okay? Any question about odd ratio? And Z is nothing but log of odd ratio. And friend, please keep this thing in mind. What is Z? Z is nothing but the log of odd ratio. And E raised to the power Z is odd ratio. And Pi is equal to 1 over 1 plus E to the power minus. That's how we get this. So friends, I hope you are able to understand it. Any question anybody is having about this terminology which we are having, which we are using here? So finally, my logic model is log of odd ratio is equal to Z, that equal to alpha plus beta x plus alpha. Okay. And the estimation method which we use here is the, again, maximum likelihood method. That's the method we use for estimating the logic model. Okay, so let me summarize. If I'm using the cumulative standard normal probability distribution, I get Probit model, which I can estimate by making use of maximum likelihood method or maximum likelihood estimate. If I'm using the logistic function 1 over 1 plus e to the power minus z, then I'm getting logic model, and again that is estimated by maximum likelihood. In this context, we also discuss about odd ratio. Right, so I hope all of you get all clarity about the concepts which we are going to use in our further discussion. Any one of you have any doubt, you are most welcome for it. Okay, so can we predict who is going to have value of 1 and who is going to have a value 0? Yes, we can do it by taking some threshold limit of probability. So you're going to get value between 0 and 1. Somewhere you have to draw a line. Those who are in this range, they belong to success. And those who belongs to this range, that belongs to failure. And we have a threshold point, which is this threshold point. What it should be, that is decided by the researcher himself. It can be 50%, 60%, 70%, anything. Okay. So normally you will find all these softwares are taking 50% as a threshold point. But they give the freedom to the user to change that threshold. That's default. Madhu is having a question about time series. If we have negative values in data, can we use log? All right. Anybody like to answer that question? Madhuji, I will come back to you for a minute, after a minute. Okay, so friends, I hope you are able to understand the whole framework of the logic and Probit, and to use them for prediction purposes. I am telling you, you need a threshold point for the probability, and most of the softwares are taking a default threshold, which is 50%. But you are also given liberty to change that particular threshold. Okay. So our next challenge is, once a logic or Probit model is fitted, then the question is how to get the best fit for the model. Okay. So friends, that's for the time being. And This issue we will take after the break. Okay, so Madhu is having a question. Can we, if we have data negative, can we take the log of it? The answer is no, you cannot take the log of the negative number. That's not defined. And Pratik is rightly saying that. And but Madhu is asking then how to proceed with that data. But Madhuji, I'm interested in asking you a question. Why do you want to take a log? Log की क्या जरूरत पड़ रही है आपको? मधु जी, आप अपने को अनम्यूट करके मुझे बताइए कि आपको लॉग की क्यों जरूरत पड़ रही है?
गुड आफ्टरनून सर।
गुड आफ्टरनून। हाँ मधु जी बोलिए।
सर मेरा एक स्टडी मैंने एक स्टडी स्टार्ट किया था कि एफआईआईज का नेट फ्लोज किन किन फैक्टर से अफेक्ट करता है, तो उसके लिए सब पेपर्स में लॉग मॉडल्स यूज कर रहे थे वो लोग, तो मुझे लगा कि उससे थोड़ा स्टेबिलिटी ज्यादा होगी, तो इस वजह से मैं ये ऑप्शन को लेके चल रही थी।
तो वो लॉग कैसे ले रहे थे? कि इनफ्लोज तो पॉजिटिव भी हो सकते हैं, नेगेटिव भी हो सकते हैं।
यस सर, तो कुछ लोगों ने तो लिया हुआ था उसके बाद भी, बट मुझे नहीं पता कैसे लिया था, और कुछ लोगों ने क्या किया था कि सिर्फ इनफ्लोज पे स्टडी किया था, नेट फ्लोज पे स्टडी नहीं किया था।
अच्छा,
तो इसके लिए मेरा
तो कर सकते हो, इनफ्लोज पे तो कर सकते हो कि इनफ्लोज तो हमेशा पॉजिटिव ही होंगे।
यस सर।
ठीक है ना, लेकिन किसी ने अगर नेट लेके लॉग लगा रखा है वो एब्सोल्युटली गलत है, वो पॉसिबल ही नहीं।
ओके सर, अगर मैं नेट फ्लो पे विदाउट लॉग आगे प्रोसीड करती हूँ तो ये ठीक है?
क्यों नहीं ठीक है, इसमें प्रॉब्लम क्या है?
ओके सर, और अगर सर इंडिपेंडेंट वेरिएबल्स विदाउट लॉग लूं या लॉग के साथ लूं, तो वो तो इंडिविजुअल डेटा पे
लॉग लेने का इशू क्यों आता है? आप कोई पार्टिसिपेंट मुझे बताइए कि लॉग हम क्यों लेते हैं?
सर वेरिएंस स्टेबलाइज हो जाते हैं और स्टेबिलिटी ज्यादा दिखता है लॉग डेटा में।
और भी कोई रीजन है? अगर मान लीजिए मधु जी आपका डेटा थाउजेंड्स में है, राइट?
यस सर।
आप उसको करोड़ में कवर करो तो कितना होगा? 5,000 will be how many crores? 50 crores। तो वैसे अपने स्केल डाउन हो गया, वैसे वेरिएशन कम हो जाएगा।
ओके सर।
नहीं होगा?
जी सर, हो जाएगा। तो सर ऐसा कुछ प्रॉब्लम नहीं है कि हम लोग टाइम सीरीज में लॉग के साथ नहीं करें तो कॉमन, मतलब ठीक है?
हाँ, कोई प्रॉब्लम नहीं, वो तो आपको अपने देखो ना नेचर क्या है।
ओके।
अच्छा, लॉग तब लेते हैं जब डेटा मेरा एक्सपोनेंशियली बिहेव कर रहा हो, तो लॉग लेने से वो लीनियर में कन्वर्ट हो जाता है।
ओके सर।
ठीक है, तो हम लेते हैं।
जी ओके, थैंक यू सर। जी
अच्छा मधु जी रुक जाओ, अभी होल्ड करो, स्टोरी अभी कंप्लीट नहीं हुई है।
यस सर।
अगर आपको लॉग लेना ही है, किसी भी रीजन से लेना है,
जी
ठीक है, और नेगेटिव वैल्यूज हैं,
यस सर।
जैसे प्रतीक जी बता रहे हैं, आप एक कांस्टेंट उसमें ऐड कर दो।
सर तो ये किसी भी डेटा में पॉसिबल है या मतलब?
सभी डेटा में पॉसिबल है, क्योंकि एडिंग ए कांस्टेंट, सब्ट्रैक्टिंग ए कांस्टेंट डज नॉट इंपैक्ट योर रिजल्ट्स।
ओके सर।
क्योंकि अगर कोई कांस्टेंट ऐड होता है तो आपको याद है एस्टिमेट्स कैसे आते हैं, बीटा की वैल्यू कैसे आती है?
सर रिग्रेस करके?
नहीं, बीटा का फॉर्मूला क्या होता है? कोवेरिएंस बिटवीन एक्स एंड वाई।
यस सर, अपॉन स्टैंडर्ड डिवीएशन। यस सर।
अगर आप कांस्टेंट ऐड करते हो तो कोरिलेशन में और कोवेरिएंस में कोई फर्क पड़ेगा?
नहीं सर।
नहीं पड़ेगा। अगर आप कोई कांस्टेंट ऐड करते हो तो स्टैंडर्ड डेविएशन वेरिएंस में कोई फर्क पड़ेगा?
नहीं सर, इतना कुछ नहीं पड़ेगा।
बीटा में भी फर्क नहीं पड़ेगा।
यस सर।
तो प्रतीक जी ठीक कह रहे हैं, आप कोई कांस्टेंट ऐड कर लो, सबको पॉजिटिव बना लो और फिर उनका लैग ले लो।
ओके सर। एंड जब रिजल्ट्स आएंगे तो वो कांस्टेंट को वापस से रिड्यूस करना पड़ेगा फॉर एक्चुअल वैल्यूज?
रिड्यूस नहीं होगा, तो देखना पड़ेगा कि किस तरह से आ रहा है।
ओके ओके सर।
क्या यूज कर रहे हो, क्या मेथड यूज कर रहे हो। ये तो
जी
मैंने
जी
ओएलएच का बताया ना आपको।
यस।
ओएलएच में तो बीटा की वैल्यू पे फर्क ही नहीं पड़ेगा।
ओके सर।
ठीक है ना। और बाकी
जी सर।
मुझे नहीं पता कि क्या मेथड यूज करोगे, क्या नहीं यूज करोगे और उसका क्या इंटरप्रिटेशन होगा, but that is also one of the solution as Pratik is saying, that's right, वो आप कर सकते हो।
ओके सर।
ठीक है,
जी
anybody else? Okay, so no more questions. So then friends, we break, and after the break, we will come back again and continue with our discussion. Okay, right? So Sachin, we break for lunch, and so 2:40 we will be back.
Sure, sir.
Right. In the meantime, if any participant is having any question, they can put that question in the chat box.